This is a cartoon that represents the relationship between voltage, current, and resistance. The voltage is pushing the current through. The current is in amps, and the resistance is in ohms. It is the restriction on the current. The more you push, the more current goes through, and the more restriction, the less. This is a simple circuit that has a source of EMF, a source of energy. It's a battery. The battery has lots of plus charges on the one side and negative on the other side. It is connected through a wire to a resistance, in this case a light bulb with a thin wire inside, and then it is connected to a switch that turns on and off, allowing the current to go through, and when it goes through, the light is on. This is the battery. It's the source of electromotive force. It has stored potential energy that you pay for, and it's measured in volts. It has an excess of plus charges on one side and negative charges on the other side. The light bulb is a wire that is very long, and it's made of tungsten, very thin, and it has a resistance, and that resists the flow, allowing the light to go on. This is the switch that merely turns on and off, allowing the circuit to be completed. The relationship between the voltage, the current, and the resistance is indicated by Ohm's law. V equals I times R. The higher the voltage, the higher the current that flows in the circuit, and the higher the resistance, the lower the current involved. So the voltage, higher current. So this is the first element that we were talking about, the battery, the source of energy. So it has lots of plus charges on this side, negative charges on this side. So it has energy stored, that's why you have to pay for it. Okay. We have another battery also. It's also plus and minus, 1.5 volts each. Your circuit comes with a battery holder. This battery holder is to mount the batteries in, negative side to the spring. One is mounted in one direction, the other one in the other direction, and they both connect together, and 1.5 and 1.5 will amount to 3 volts. And so you can see there's one plus side and the minus side. Okay, if we place this over here on the circuit board, so this is called a snap circuit. We have a wire here, just connecting wire. We can take our second element, which is a resistance. It's a load resistance. Basically, it takes electrical energy and converts it into another form of energy. Okay, in this case, we're connect the plus side here and the minus side there. So we will have that element of the circuit. And the third element is a switch. In this case, it's a toggle switch on and off. You can see the on and off positions. It's referred to as S1. And so when we connect this, it's still an open circuit and the light does not go on because we don't have the switch on. If we put the switch on in this case, then electricity is flowing conventionally from the plus to the minus side. As it goes through this resistance, it will fight its way and heat up the wire inside. So this is merely a wire, and it heats it up so much that it glows. Okay, if we open the circuit, so now the circuit is not complete and the light will go off.